All right, good afternoon, everyone. We're going to get started. We're all here for the Swale on Yale presentation by David Schwartz. So David Schwartz has 36 years of experience in civil engineering and is a principal with KPFF. He does sustainable development and creative treatment and use of stormwater are a cornerstone of David's practice. He starts with conceptual design and coordination with other disciplines and carries through to working with the contractor for proper installation. He is LEED or LEED accredited and founder of the KPFF Seattle Sustainable Design Group. A significant portion of David's experience includes urban infill projects. He's active with Engineers Without Borders program and started the KPFF internal lead group. I forgot to introduce myself. I'm Abby Stockel with the Department of Ecology, and you've all heard this probably a million times today, but this presentation will be recorded, but not the Q&A. And please turn off all your cell phones, and I'll give it over to David.
Thank you. So I was told that I have to talk into the microphone, even though I got a really loud voice, and I would normally just walk and talk and do all of that because it helps with the filming. But when we get to Q&A, I'll get back out behind this lectern because I'm not a big lectern person. So the Capital Water Quality Improvement Project that we did with the City of Seattle was something that was actually thought up by the City of Seattle, and then ultimately it got implemented through a public-private partnership with city investors, which city investors is Vulcan Development. For those of you who are in the City of Seattle, you'd know who Vulcan Development is because they've developed probably 3/4 of South Lake Union, and it was Paul Allen's company. So we got involved in this project because we were actually working for the development group that was building the building, that was city investors in Vulcan, through KPG, which had an on-call with the City of Seattle for doing stormwater improvements. And so between KPG, KPFF, and SPU, we worked together to implement the project. The project drains a 435-acre, very urban area off of Capitol Hill. How many people here are from the greater Seattle area? So a bunch of you. Okay, so you already know that Capitol Hill is very densely developed with housing and lots of roads and apartments and et cetera, et cetera. And all this water used to come down and go out into Lake Union completely untreated. So this is more or less an end-of-system treatment facility that we put in. It's not completely at the end of the system, but it's pretty close. The project area is here, down in South Lake Union area. There were some very simple kind of project constraints. Where we're going to be building this is a very dense urban developed area in South Lake Union. There were a plethora of existing utilities, including 5 different communications companies, a very large electrical duct bank for Seattle City Light that was maybe 30 inches below the surface. There was a 100-year-plus old water main that went through the area that was no longer in use, but it was in the way. There's gas lines that were in the way that we had relocated that ended up still in the way. One of the telltale issues. The existing drainage system that was there is pretty shallow. There were limited public funds, which is never different. There's always limited public funds, and there was limited space in the right-of-way to do things. So the general plan was to go and bring water that was coming down off Capitol Hill, which came down Denny Street, and divert it out of the main line that it was coming into a parallel system that would allow for this to go through and get water quality treatment for the lower flows. During higher flows, it would just overflow back into the existing conveyance system. And that was a really important thing, is even the swales, after the water goes through the swales, it goes back into that same pipe that discharges out into Lake Union. That way we didn't have to create any additional outfalls and go through the entire process of having to get permission for additional outfalls. In the end, there are 4 swales. The first 2 swales got built on the north end, and I'll talk about that more later. The treatment capacity of this is roughly 7.2 cubic feet with all 4 swales online, which they will be as of next spring, they'll all be online. The second set of swales got finished being built in January of this year. And it was really important because this is going next to a private development that it was an amenity. It wasn't just some, this thing that got tacked on. So the public-private partnership, as I said, was really important. The city spent a lot of time putting together a memorandum of agreement with Vulcan. It outlined a whole series of different things, including who was going to maintain it, how much Vulcan was going to be their contribution to the city for it. One portion of the swales actually has the dedication of property to the city to allow for the sidewalk to go adjacent to the swale and still have the swale put in. So a number of different items through this memorandum of agreement. This is the basic layout of the swale, and again, I'll get into more detail in the next few slides, but here's the diversion structure, which is actually on Stewart Street. It comes out, and the city actually designed this first part with some input from us. And the biggest input that we had for them and that they actually put in was adding that overflow structure there. And the idea was that we wanted to make sure that throughout the system that we weren't getting a lot more water than was intended into the swales so that it didn't cause flush through of the swales. So we put overflows in the flow splitting structures, and we put an overflow here. So the first piece is this diversion structure, and then it goes from the diversion structure through the overflow system and then to a Vortechnics swirl separator. So the swirl separator is taking out floatables and heavy sediments. And it worked really well. I have a picture a little later on that will show you just when it was first put online how much of the floatables were coming out of the system. So a little closer in, again, here's the various different things. Because the construction of the swales was directly tied to the construction of the private development, we ended up building the northern portion of the swales first. This flow splitter device and the diversion structure and everything, that's on the very south end of this system. So the piece in the middle just got done in January. The piece on the north end was done, I believe it was 6 years ago now. It's been a long time. So the city did everything up to right there, and then KPFF and KPG took over the design and took it the rest of the way. One of the things we had to do, because we were building the northern piece first, is we had to put all the conveyance lines in for the entire system as part of the first phase of the design. We also had to relocate some other utilities out of the way for future development. But each one of the systems is controlled by flow splitter boxes, and depending on the number of places that we're sending water, we have more or less controls. They're all controlled using orifices, and then each one of the flow splitting devices has an overflow that allows it to go back into the main line. That's also important when they go to do maintenance on the swales. They want to shut the water off to the swales, and there's multiple ways of doing that. One is a sluice gate that's in the original diversion structure. The other is by pulling the elbows off that have the orifices in them and plugging the pipes that are going into the swales at the flow splitting devices. So overall, the swales, this is, again, this flow splitter first south end is down on Thomas Street, ran pipe up here to another flow splitter that then ran the water over and fed the swale. This is called the swale on Yale by us because Yale Avenue is one of the two streets, and the swale on Pontius just didn't really sound all that catchy. So Block 10 was built first, and those swales went online, like I said, about five years ago or so. The existing 72-inch line that the water is coming out of is this line here that runs up here, turns the corner, and then goes that way. And it actually runs underneath the swale as it goes from here to there. And we're putting the water back in. One thing we did not do is all the street water is not put into this swale. So we didn't want to contaminate the water we were putting into the swale with the runoff from the street directly next to it. We wanted to make sure that we were dealing with just this diversion structure. And this kind of an experimental project for the city, and some of the things that we did on the first phase of this were changed on the second phase because we learned some things, and I'll get into more of that later as well. One thing we did go through with the city, what was really important to the city, was kind of a risk assessment of what would happen if this happened, what effect would it have on the project. We ranked those in terms of the impact being really high, the probability being high, low, medium, or high, low, or medium. And then we just kind of brainstormed a bunch of different risk possibilities. And one of the bigger ones was if the developer decided not to build their building, the whole project went away. So it was really important that things continue to move forward. And that actually did delay things a little bit because there was a lull in the desire to build the building for a little while, and so it actually delayed the ultimate installation of everything. Utility investigation, as I said earlier, there's a lot of utilities in the area, so doing an investigation of where they were, how deep they were, was really important. So we had a pretty aggressive potholing program that we went through. Again, we found we got the top and bottoms of the duct banks for the electrical. We found utilities that we didn't know were there because they hadn't been on any city maps, and they weren't being actively used. So that was, the fact that they weren't being actively used actually helped. We did know that there was a few lines that were going to need to be relocated. We found some fiber optic lines that we didn't know were there because they didn't put them where they were supposed to put them. We started potholing for them, and we ended up with this line going out towards the street of potholing until we actually found out where they put them, because they just randomly put them in, which actually happens a lot in Seattle. I found on a lot of the development that I've done for various different groups, it says it's supposed to be 4 feet behind the curb, and you find it right up against the building, which makes it difficult to build because you can't get things in there. Anyway, so this program really helped in terms of figuring out elevations of the piping, and all of this is backed up. The water is backing up in the system to get into the swales. So this is a kind of a basic section. This was the first round that we did. We actually started out with a footing that came out this way towards the street, and during the construction process, it got changed to be an L-shaped footing because the contractor didn't want to dig more out into the street than they absolutely had to. So this was our first design, was footing here, footing there, swale with a liner in the middle. And the reason for the liner is, first off, the soils are not going to infiltrate water, so that was not a problem. But we were concerned about water getting from the swale into the subdrain system of the building, which is the foundation drainage system for the building. So there's a bentonite liner in the swale on the first set. And on the second set, we figured out that this was really tough to build. So we decided we would just go ahead and let the footing go all the way across. And we used Hi-Crete in the concrete, and we got rid of the liner. At one point, we were trying to put in a polyurethane liner, and the cost of that was prohibitive, and the city decided to take it out and just use the Hi-Crete instead. As I said before, we had relocations. We had to relocate a 12-inch water main that ran down through the middle of where the swale was supposed to go, and since the swale depth is about 6 feet from the top of the wall to the bottom of where everything is getting collected all together, the water line was going to be in the way, so the 12-inch water line got relocated as part of the first phase. This picture here is a dead man thrust blocking system that was put in to, there's a horizontal and vertical bend in that particular location to get back to the water line where it was going to reconnect to the main system. That's about a 10 cubic yard pile of concrete under the road. And I had the pleasure of going out and inspecting that at 4 o'clock in the morning because this is a really heavily used residential area, and they couldn't shut the water off except between like certain hours in the middle of the night or middle of the morning, depending on how you want to think of it. So the North Swale is roughly 300 feet, 10.5 feet wide on the Yale side, 16.5 feet on the Pontius side. And the reason the Pontius side got to be wider is they took the parking out in order to build the swales, the street parking. On Yale, it was parallel parking. On Pontius, it was back-in angled parking. So we had more room to work with. The intent of all the swales is to have a little over 9-minute residence time as they flow through. The primary design technique was to design them as flow-through swales, like grassline swales, with a lot of heavy vegetation. The south swales, the Yale side is slightly shorter. It's 260 feet, and that's because of existing utility junction boxes, and we actually moved several of them for Verizon and Comcast and CenturyLink and Frontier and one other one I can't remember off the top of my head, but I told you there was a lot of communication companies that had lines in the way. They were, up to a point, they were underground, and they came up a pole. We actually ended up moving the pole and moving most of their junction boxes back, but we still didn't have enough room to make the thing any longer than what we had. And then on the Pontius side, it's about 300 feet long. So the diversion structure, again, first thing is the pipe coming down off of Capitol Hill is about 48 inches. What we did is we put a saddle manhole over the top of it, took it out, and temporarily pumped the water around where they built a wall in the middle as a weir with a sluice gate in the bottom of that, and then connected a pipe so that the water can build up to the top of the wall. It still goes out through the pipe to the treatment system. Once it gets to the top of the wall, it spills over and goes back down the path that it's always gone into. Swirl separator, as I mentioned before, I'll show you a picture of what we got out of that, but that's just a standard off-the-shelf Vortechnics swirl separator, sized larger than it absolutely had to be, just so it didn't have to be maintained as often. The picture of the floatables. This is looking down inside the swirl separator about a month after it went online. So it's definitely doing its job. Kind of nasty looking, but there it goes. Mentioned before the flow splitters, they're all precast units, orifice plates used to divert the water, and overflow standpipes that allowed for both maintenance and for any high flows if we, for some reason, got higher flows through the system than we intended. This is just a picture of what those look like. The pipe network that we put in, again, had to be really shallow because it had to get over the top and under the bottom of all the existing other things that were already there. And so it ended up being a ductile iron conveyance system, and then it has little brass markers to locate it so that people know it's there every 50 feet down the road. The input to the swales is basically a trench drain. One of the modifications we made on the second half is we actually raised the trench drain up off of the box using these support things here. That was an intent to keep things from clogging up as much because the first set of swales was getting plugged up with organic and sediment material pretty early in the process. But this allows for the water to come up, swell out, and be a nice spread out flow through the swales as it goes through. We also have weirs throughout, wall weirs throughout the swale, both to allow for the drop to take place and maintain the residence time, but also to spread the water back out so you don't get short-circuiting through the system. The plant mix was another interesting thing is that and the first one we did, we planted all the plants that we were going to put into the swale in the bioretention soil mix so that we would make sure that whatever soil came off those plants didn't plug up the soils. One of the things we learned was that was a real pain to do that, and it caused us not to be able to have extra plant material when we needed it. So we went to bare root on the southern swales the second half of the project. There's roughly 20,000 plants, a huge number of plants. They're planted basically 10 inches on center, and a wide variety of plants to make the thing really look nice, and there's pictures later I'll show that. Pretty much use the bioretention soil mix that is currently 40-60. So we use something very similar to that, although it changed between the first set of the first swales that were constructed and the second. Another thing that changed is we put in a polishing layer to be able to remove phosphates because again, phosphorus increased because of the bioretention soils. So we put something in the second swale half, the second phase of things to take care of that. So these are some of the plants that were used. The idea was to get different colors to make the thing a little more interesting, but they're all in the, well, let's see. Rushes and sedges. So this is what it looked like when it got built. Lots of different colors. Things really grew kind of beyond our dreams. One thing we noticed is that some plants overtook other plants. So in the second set of swales, we planted a different mix of things because some of the plants didn't survive in the first one. They're even in little microclimates, like they survived on one side of the building and they didn't survive on the other because it's more in the shade. These are some of the streetscape elements along the edge that made it more attractive to the developer next door in terms of both seating, curbing, and this kind of rolling, flowing metal edging piece. We also put in interpretive signage for people that are coming by so they can see what this is actually supposed to be doing. We put in pedestrian bridges at mid-block crossings because that's something that the developer wanted and the city was okay with. Ultimately, the City Department of Transportation maintains those. The maintenance of the swale itself is done by Seattle Public Utilities. This is just a picture of the first bridge going in. One of the nice things is it's next to what was an old laundry building, and we took steel members out of the old laundry building and used them to build this bridge. So that was a nice sustainable piece. The city put, as part of this, because again, it's kind of a demonstration type project, they put in monitoring facilities on, and we have that also for the second set of swales that are going in. The first set they were monitoring on the Yale side, and they'll be monitoring both sides on the new ones. So again, kind of a phased different sets of construction. Some street improvements were done by the city, some by the developer, and this is just a quick run through of what the various different phases of what we're getting done. Picture of the diversion structure, the swirl separator, the beginnings of the construction of the swale, one of the flow splitting devices. Again, this is the picture on the left is the first round where we actually built the footings out on either side instead of all the way across. Some of the planting going on, and the edging material. One nice thing we got is the Design Commission at the City of Seattle actually created an award just for this project because they were so psyched about how it turned out from a design standpoint. So we got this on the boards award from them, which was nice. It's nice to get awards as an engineer. You don't get them very often. Removal. This is the most important thing to me is this is the most important part of this. The removal rates on this were fantastic, and actually the city's private consultant that monitors their systems for them told us that this was the best stormwater quality facility the City of Seattle had, hands down. So you can see amazing amount of removal of suspended solids. Copper reductions really high, phosphorus reductions not so high. Flow reductions actually surprisingly higher than I would have expected. The end system actually has bioretention soils that allow infiltration, which is one of the reasons we get such good suspended solids removal. There's an underdrain pipe in it, and so we have both surface flow and underdrain flow in the system. Orthophosphates actually went up, which is why we added that material in the second set to pull that out of the system. One of the issues in terms of lessons learned is there's significant sediment loading, way more than I think we had anticipated. Bioretention soils increased, as I said before, the orthophosphates. Putting the liner in was a pain, and trying to build the whole thing with the footing separated was a pain, so we didn't do that on the second half. Originally, the grate sat down on top of the trench drain at the beginning. You can see this is a picture of it kind of sedimented up already. That happened pretty fast, so we lifted them up on the second round. They've recently finally got around to trying to do some maintenance, or more active maintenance on this. It went relatively untouched for a while, and they're trying a variety of different things. And none of them have worked really ideally yet, but we're still working with them to come up with different ways that we might be able to make it simpler to maintain. One thing I would advocate is this is treating about 435 acres. if you thought about trying to treat a bunch of 30, a bunch of even, if you do like say 40 acre sites, once a year, you could come in here and maintain this thing 10 times a year for the, and I think it needs to be maintained maybe 4 or 5 times a year, at least during the really rainy season when there's a lot of leaves on the ground. It needs to be maintained more often. And this is a picture of what it looks like on the Yale side today. I think that's yep, that is it. So with that, hopefully I didn't run too much over. Question time.